Here we go again. All right, we talked about igneous rocks, we talked about sedimentary rocks, and now we're going to talk about change, people. Change, just like our whole society has momentarily changed. We are going through a metamorphosis. Ooh, actually, I got to grab that last reference table piece because here it is, the wheel of rock. Let's show that first. Let's show where we're at. There we go, the wheel of rock. And what is producing metamorphic rocks? Well, change. Okay, what kind of change? Well, first of all, you might be asked in the exam, what type of rock can become a metamorphic rock? According to the chart, any rock can become a metamorphic rock. Let me ask you a different question. Let's back up a second. What type of rocks can form out of magma? Only one. Magma only solidifies to make igneous rocks. Now, igneous rocks can break up or they could get heated and or pressurized. Either both or one or the other. And they'll change into metamorphic rocks. Or they could be made into sediments, into sedimentary rocks, and then they can get heated or pressured into a metamorphic rock. What the heck? Even a metamorphic rock can get heated or pressured and form a metamorphic rock. Watch that in slow motion. There it is. And then if it melts though, if the heat and pressure goes over the edge and it melts, no chance for a metamorphic rock. If it turns into gooey earth material called magma, it can only solidify and form igneous rocks. So we're talking rocks that get heated and pressured, but not to the point where the material melts. Now, it happens in two different ways. There's always this two different thing. With igneous rocks, intrusive, extrusive. With sedimentary rocks, those that are made up of land-derived particles or the evaporation and precipitation rocks. And with metamorphic rocks, no different. Either those that form over a whole giant region that gets heated and pressurized, like a mountain building episode. Stop! Okay. Heated and pressured, or someone just reaching out and touching someone, as if I were to take a red-hot iron, just like red-hot magma, and just touch it to the side of my face. My face would probably never look the same. Who knows? It might be an improvement. But it would change. In fact, sometimes in rocks, it is an improvement. Even though they get touched by magma, it ends up looking better than when they started. We call those contact metamorphic rocks. Let me show you what I mean when it comes to this contact versus regional stuff. It has to do with this. By the way, this is a worksheet you guys will be working on if you were here, but you're not. I'm just here, you're not. Okay, so here's the deal. Okay, let's deal with this one down here. So, a bunch of rocks are minding their own business. Maybe they're a bunch of shale. Maybe they're sandstones. That's sandstone, shale's way out there. And maybe a little granite, and they make up a mountain. And then what happens is this mountain starts to become volcanic because there is a subduction. Subduction of oceanic crust, basaltic oceanic crust. Page 10, Earth Science Reference Tables, density 3.0 grams per centimeter cubed, upper right-hand corner. Page 10, Earth Science Reference Tables. Oceanic crust. This is light and chewy, not really, just light. Continental crust. This is continental crust, mostly granitic. But we got some sandstones, we got some shales, we got other things going on. And what happens is magma comes up because of all the heat and pressure from what's called the subduction in the next unit. It creates a tremendous amount of entire region pressure. Get it? Entire region. Regional metamorphism. So what happens? These rocks get really stressed out. So what happens is granite is actually this solidified now and formed granite rock, but this was the most stressed out rock that got changed. So we call this one on the reference table, the most metamorphic is called gneiss. Now, G-N-E-I-S-S, gneiss, G-N-E-I-S-S. I used to have a bumper sticker on the back of my truck. It said, it's a nice day, don't take it for granted. If you want to see people get tongue-tied behind you in their car trying to say the word nice, it's awesome. Now, if it's not nice, I know you'll never forget this. Never will you forget this. If it's not nice, it's just a piece of schist. Don't forget it. If it's not schist, it's phyllite. If it's not phyllite, a little bit less metamorphism is slate, and not metamorphic at all is shale. So let's go the other way. Shale, slate, phyllite. Oop, I missed one. Shale, slate, phyllite, schist, Nice. And that's the metamorphic sequence of regional metamorphic rocks. I'm going to show you what I mean in a second. And then we get a little bit of this magma, before it turned into granite, actually touching this sandstone. And that's called a contact metamorphic situation. A better example of that is up here. So here you have some sandstone minding its own business. You have some shale, it's good for the day. And you have some limestone. By the way, these are all official USGS, United States Geological Survey. They're all official symbols for these rocks. Here comes this magma. These rocks were having a great day. Nothing was bothering them. Up comes this magma. What it does, it touches these other rocks. Now, it doesn't touch the rock out here. It touches the rock right here. The symbol we use are these little lines. Those lines indicate what's called contact metamorphism. So right there, what would happen is you would go from limestone into the contact metamorphic form of limestone. I'm going to show you that right now, even though we haven't shown the chart yet. Because it goes from what is a fairly dull rock, I mean really cool because it has fossils and stuff usually, but it goes from that kind of rock into something fantastic, which people use for building stones all over the world. So here is a piece of limestone. This is limestone, we call this limestone. It's made by evaporation and precipitation. And when magma comes out and touches this rock, it turns it into this. The calcite shows through, being a lighter colored, beautiful mineral. Some dead, decayed plant and animal matter comes through, getting squished and getting squeezed and getting changed. And even some other minerals that are sprinkled in. And it forms an incredible building stone, which is used throughout Europe and the world for carvings, beautiful stones. We're talking Michelangelo here, right? Anyways. This is what we're talking. This could be made into this. It's a beautiful carved elephant, missing a few pieces now, made out of marble. This is the sedimentary rock. This is the contact metamorphic rock. Now I'm going to show you the chart, and then we'll actually look at the rocks. On the chart for metamorphism, okay, we have this right here. All right, we have, pay attention guys, regional and contact metamorphic rocks. Low-grade metamorphism is when shale turns into slate. I said that was the least metamorphic. The closer to the core of the whole region being heated and pressurized is phyllite. This is a very concise description of what phyllite is. If it's not phyllite, it's a piece of schist. S-C-H-I-S-T. Don't spell it wrong. Anyways, platy microcrystals. And by the way, you want to know what makes them up as far as minerals? You just go right across. Whatever minerals you go through, those are the minerals that are in that metamorphic rock. Slate is only made up of mica. Phyllite is only made up of these 5. Some pieces of schist might contain pyroxene. But if it's not a piece of schist, it's something that's really nice. And that is the highest form of metamorphism. I'm going to show you what these look like. We're going to take a personal up-close look of these right now. Now, this is the progression we're talking about. This is a piece of shale, sedimentary rock. It gets metamorphosed in a regional mountainous area. It turns into slate. People will use this actually for roofing tiles. It's a very, very expensive roof. You see this in downtown Buffalo with a lot of the big, beautiful homes down there. They're made of slate because it's impermeable. Remember topic 8? Topic 8, impermeable. Water can't get through because not only clay, but squeezed clay forming metamorphic shale, which is called slate. As it gets more squeezed, it starts to take on a layered appearance, and it gets wavy. That's called phyllite. Then it gets both shiny and wavy. And when it gets shiny and wavy, it turns into schist. This is actually from the Blue Mountains of Vermont. Yours truly actually grabbed this one himself. Okay, and then the ultimate is the minerals don't get they just don't get like layered. And I hate to use that term. They don't get aligned. That's the term we want to use. They don't just get aligned, but the minerals actually, in a jelly-like mass, start to join with other minerals of like density that they actually form a striping. But we specifically call that striping banding, like you're wearing a headband. And when the minerals are banded, that is the most identifiable metamorphic situation possible. That is called gneiss. Shale, slate, Phyllite, schist, gneiss. Regional metamorphic. And we already showed the contact metamorphic. A good example is limestone, or what I call limestone, turning into marble. Let's go back to the chart. Hang in there, guys. I don't want you to get too dizzy here. A little bit dizzy with the camera, but that's okay. Here we go. So now we're on the chart, and you're going to be asked questions. I'll turn off the lights while we're regrouping. And here we go. So you're going to be asked questions. Which rock is the most metamorphic, the highest grade of metamorphism? High grade metamorphism. It's nice, okay? Now I did use the term shiny to describe phyllite, but even shinier with larger mica crystals, okay, is schist. Look at this. The only time the word banding is used in your whole reference table is to describe pieces of gneiss. Could schist be banded? No. Are the minerals aligned? Yes. Does it look like layering with sedimentary rocks? Yes, but we don't call it layering. We call it layering only with sedimentary rocks. With metamorphic rocks, you call it mineral alignment. They're all given a crazy word called foliated, like folded towels. That alignment, that, use the term layering of those folds, are what makes up regional metamorphic rocks. Now, rocks where magma just reaches out and touches something, that doesn't show any mineral alignment. That's just the side of my face would look all shiny and distorted. And that's what happens under contact metamorphism. So what do you get? You get normal coal that turns into anthracite coal. How the heck are you supposed to know that? It says it in the reference table. How do you know what type of rock the metamorphic rock quartzite formed from? It forms from normal sandstone. Sandstone that gets extra squeezed and shiny forms a beautiful building stone called quartzite. And of course, marble, the beautiful building stone that it is, forms from the metamorphism of limestone or dolostone. Does marble have calcite in it? Yes. Uh-oh. What could marble do then with acidic rainwater mixing through the air or mixing through the vegetation in the soil? It's a problem. Over in Europe, where there's lots of pollution, not to say we don't have any, it rains down on these statues. Let's say you're the statue of David. You're starting to have some of your parts dissolve away. Now, including all his parts, dissolve away. You better move him inside. And that's exactly what they did in Italy. They moved him inside because it's made up of marble, which is a form of limestone, which is made up of calcite, which on page 16 slowly dissolves in acid, in this case, rainwater. You got to deal with it. A lot of statues are dissolving in Europe because most of them are made up of marble. They should have made them out of granite, but that's it's more expensive and stuff like that, and not easy to cut. And then there's other ones. What a conglomerate rock could form a metaconglomerate. Guys, it's all here on the chart. These are called non-foliated. There's no mineral alignment. There's just a different look. These are called foliated, and that, ladies and gentlemen, are metamorphic rocks. Next on the stage, what happens when they move around.